Hello everyone, welcome to Brainstem. Today we're gonna start a new topic, game theory. Before we get started, let me ask you a question. Why do we have bigger brains? Well, we probably did not evolve big brains to make tools. Rather, we evolved them to deal with other primates. Smarter primates had more babies because they could manipulate the rest of the tribe into giving them more resources. However, this does not mean tricking others, although it can, but can also imply better coordination and making the entire tribe better. And social neuroscience is the study of the brain in the context of social stimuli. Social neuroscience has been proved to be very difficult to study in laboratory conditions. One methodology for studying social thinking is game theory. Scientists can place multiple subjects into situations where their actions affect the rewards that others get. This means that subjects are forced to think about the mental actions of others in order to maximize their own reward. The ability to reason about the mental states of others is called theory of mind, and several regions of the brain are associated with theory of mind, and there are several disorders, for example, autism, Williams syndrome, that affect the ability of people to do social reasoning. By placing subjects into controlled situations, we can alter social environment and see how humans/animals behave in known conditions. Using fMRI and lesion studies, several areas of the brain have been identified to be involved with various aspects of social behavior. Let's start with prefrontal cortex. It deals with reasoning, understanding, and uncertainty. Damage to it will result in damage to socialization and self control. It is critical to properly functioning within society. We also have ventral striatum. It is activated when thinking from another's perspective. If you were to play these games against the computer and know it was a computer, then this part of your brain would not light up. Don't worry, we'll dive into those games later. And finally, we have orbitofrontal cortex. It is involved with value assignment. When you're judging the pros and cons of betraying and trusting, or deciding whether you want to betray, this part of your brain is activating. Now let's look at a case of prisoner's dilemma.
Two perfectly rational gingerbread men, Crispy and Chewy, are out strolling when they're caught by a fox. Seeing how happy they are, he decides that instead of simply eating them, he'll put their friendship to the test with a cruel dilemma. He'll ask each gingerbread man whether he'd opt to spare or sacrifice the other. They can discuss, but neither will know what the other chose until their decisions are locked in. If both choose to spare the other, the fox will eat just one of each of their limbs. If one chooses to spare while the other sacrifices, the sparer will be fully eaten, while the traitor will run away with all his limbs intact. Finally, if both choose to sacrifice, the fox will eat 3 limbs from each. In game theory, this scenario is called the prisoner's dilemma. To figure out how these gingerbread men will act in their perfect rationality, we can map the outcomes of each decision. The rows represent Crispy's choices, and the columns are Chewy's. Meanwhile, the numbers in each cell represent the outcomes of their decisions, as measured in the number of limbs each would keep. So, Do we expect their friendship to last the game? First, let's consider Chewie's options. If Crispy spares him, Chewie can run away scot-free by sacrificing Crispy. But if Crispy sacrifices him, Chewie can keep one of his limbs if he also sacrifices Crispy. No matter what Crispy decides, Chewie always experiences the best outcome by choosing to sacrifice his companion. The same is true for Crispy. This is the standard conclusion of the prisoner's dilemma. The two characters will betray one another. Their strategy to unconditionally sacrifice their companion is what game theorists call the Nash equilibrium, meaning that neither can gain by deviating from it. Crispy and Chewie act accordingly, and the smug fox runs off with a belly full of gingerbread, leaving the two former friends with just one leg to stand on.
Now let's do some discussion. First question. What does this scenario remind you of in your life? And second, this is one way to measure prosocial versus antisocial. How might you use it in an experiment? And third, how might one get out of mutual defection if someone betrayed you? And how might you play the game if you didn't know when it would end? Well, no matter how you think of it, prisoner's dilemma is pretty common in our lives. For example, working on a project together, someone might defect and let you do all the work. And one way to apply this into experiment is that cocaine addicts, people in prison, and sociopaths defect a lot more than normal people. And people on oxytocin defect a lot less. And as for the other two questions, let's watch another clip which provides a trace of thought.
Normally, this is where the story would end, but a wizard happened to be watching the whole mess unfold. He tells Crispy and Chewie that as punishment for betraying each other, they are doomed to repeat this dilemma for the rest of their lives, starting with all four limbs at each sunrise. Now what happens? This is called an infinite prisoner's dilemma, and it's a literal game changer. That's because the gingerbread men can now use their future decisions as bargaining chips for the present ones. Consider this strategy. Both agree to spare each other every day. If one ever chooses to sacrifice, the other will retaliate by choosing sacrifice for the rest of eternity. So, is that enough to get these poor sentient baked goods to agree to cooperate?
Well, now that you've watched the video, feel free to try this game with your friends, classmates, or families to find your best strategy. For now, we'll move on to Dictator Game. It is a simple two-person game. The dictator has an amount of money. He or she may choose to give any amount of money, from none to all of it, to the other person and keep the rest. The other person could reject it and will cause neither of them to get anything. Feel free to pause the video here and find a friend to play with you. You could use anything in replace of the money here. For example, candies, chips, basically anything. You and your friend should take turns to be the dictator. And do remember to record your reactions, emotions to the offers given by the dictator. Now that we've had some game experience, let's look back at it. When you're given an offer by the dictator, was your reaction to this a reasoned, logical argument, or was it an emotional reaction? Why might we have a built in reaction against unfairness? Well, despite how you and your friend played this game, Research shows that even when the game is completely anonymous, on average, the dictator or the proposer of the splitting plan still gives about 28.35% of the money to the other person or the receiver of the money. It means that we still have an instinct of caring about other people, and we do think of our own benefit as more important. Do remember that, as we just discussed, there is a case that when the discontent of the receiver builds up to a certain level, um, the receiver will start to reject the proposal out of, and that's something we could think about during or after we play the game. So that's all the material we have for Game Theory 1. Thank you.